Hello and welcome. In this tutorial from Math Zone African Motives, we will explore a fundamental concept in matrix algebra. Today, our focus is on understanding the cofactor of an element in a matrix. By the end of this video, you will be able to define what a cofactor is, understand its components, and confidently calculate cofactors for elements within any square matrix. This is a crucial skill for more advanced topics like finding the inverse of a matrix or solving systems of linear equations. So what exactly is a cofactor? It's a key term we need to define. The cofactor of an element in a matrix is the product of two parts, the minor of that element and a specific sign determined by its position. You can think of it more simply as a signed minor. We've learned about minors in a previous lesson. To briefly recap, a minor is the determinant of a smaller matrix formed by removing the row and column of the element we're interested in. Now let's talk about the signed part. The sign that we multiply the minor by is determined by the element's position within the matrix. For a 3x3 matrix, the sign pattern follows this structure: plus, minus, plus in the first row, minus, plus, minus in the second, and plus, minus, plus in the third. This alternating pattern is how we get the sign part of the cofactor. We'll see why this pattern works in a moment. Now let's put this into a formal definition using a formula. This formula combines everything we've just discussed. The cofactor of an element at row I and column j, which we denote as A sub ij, is equal to the quantity -1, raised to the power of I plus j, multiplied by the minor of that same element, M sub ij. Let's break down this formula, as it's the most important part of our lesson today. First, I represents the row number of the element. Second, j represents the column number of the element. Third, M sub ij is the minor of the element at row I and column j. And finally, a sub ij is the cofactor of the element. Notice the term I plus j. This is key. The sign -1 to the power of I plus j generates the sign pattern we saw earlier. If the sum I plus j is an even number, like 2 or 4, then -1 raised to that power is +1. This gives us a positive sign for our cofactor. If, on the other hand, the sum I plus j is an odd number, like 3 or 5, then -1 raised to that power is -1. This results in a negative sign for our cofactor. This is why it's called a signed minor. Let's apply this formula to a general third-order determinant to make sure we understand each piece of it. We're given this 3x3 determinant with elements a sub ij. Let's determine the cofactor for the element in the first row and first column. Our goal is to find a sub 1,1, the cofactor of a sub 1,1. We start with the cofactor formula. A sub ij equals -1 to the power of I plus j times the minor m sub ij. For the element a sub 1,1, we have I equals 1 and j equals 1. Plugging these values into the formula, we get -1 to the power of 1 plus 1, multiplied by the minor m sub 1,1. The exponent 1 plus 1 is 2, which is an even number. Therefore, -1 to the power of 2 is +1. This gives us our sign. Now, we need to find the minor, m sub 1,1. Remember, we find the minor by crossing out the row and column containing a sub 1,1. By removing the first row and first column, the remaining 2x2 determinant is the minor. This minor is composed of the elements a sub 2,2, a sub 2,3, a sub 3,2, and a sub 3,3. The minor is the determinant of this 2x2 matrix, which is calculated as a sub 2,2 times a sub 3,3 minus a sub 3,2 times a sub 2,3. Combining the sign and the minor, we get the cofactor a sub 1,1. It's +1, multiplied by the determinant of our minor. This confirms the solution provided, which shows the cofactor as +1 times this determinant. Great, let's do a second example using the general determinant to solidify our understanding. This time, we will determine the cofactor for the element in the first row and second column, which we call a sub 1,2. Our goal is to find the cofactor a sub 1,2. Again, we start with the formula. A sub ij equals -1 to the power of I plus j times the minor m sub ij. For a sub 1,2, our row number I is 1 and our column number j is 2. So the exponent becomes 1 plus 2. We have -1 to the power of 1 plus 2, multiplied by the minor m sub 1,2. The exponent 1 plus 2 is 3, which is an odd number. -1 to the power of 3 is -1. So the sign for this cofactor will be negative. Next, we find the minor m sub 1, 2. We do this by crossing out the first row and the second column. The minor that remains is the determinant of the 2 by 2 matrix containing the elements a sub 2, 1, a sub 2, 3, a sub 3, 1, and a sub 3, 3. The determinant of this minor is a sub 2 1 times a sub 3, 3, minus a sub 3 1 times a sub 2, 3. Finally, we combine the sign -1 with the minor. The cofactor a sub 1, 2 is -1 multiplied by the determinant of our minor. This matches the provided solution perfectly. Now that we've seen how the cofactor formula works with general elements, let's tackle a concrete example with numbers. We are given this third-order determinant. Our task is to calculate the cofactors for 3 specific elements, 2, 7, and 9. We will solve each one step by step. Let's start with the first part. Let's calculate the first cofactor in example 1.5. First, we need to calculate the cofactor of the element 2. The element 2 is in the second row, first column, so its row index I is 2 and its column index j is 1. Its position is 2, 1. We use the cofactor formula. A sub ij equals -1 to the I plus j power times m sub ij. Plugging in our values, we get a sub 2, 1 equals -1 to the 2 plus 1 power times m sub 2, 1. The exponent is 2 plus 1, which is 3. This is an odd number. -1 to the power of 3 is -1. Now we need the minor m sub 2, 1. We find it by crossing out the second row and first column. The minor is the determinant of the 2 by 2 matrix composed of 3, 9, 7, and 2. The value of this minor is 3 times -2 minus 7 times 9, which gives us -6 minus 63, resulting in -69. Now we combine the sign we found earlier with the minor. The cofactor a sub 2, 1 is -1 times -69, which equals +69. The solution in the document also gets 69, so our calculation is correct. We have successfully found the cofactor of 2. Let's move on to the second part of the example and find another cofactor. This time, we will find the cofactor for the element 7. The element 7 is located in the third row, second column. So, I is 3 and j is 2. Its position is 3, 2. Using the cofactor formula, a sub 3, 2 equals -1 to the 3 plus 2 power times m sub 3, 2. The exponent, 3 plus 2, is 5, which is an odd number. -1 to the power of 5 is -1, so the sign will be negative. Next, let's find the minor m sub 3, 2. We cross out the third row and the second column. The remaining minor is the determinant of the 2 by 2 matrix with elements 1, 9, 2, and 0. The determinant of this minor is 1 times 0 minus 2 times 9, which gives 0 minus 18, or simply -18. Now we combine the sign with the minor. The cofactor a sub 3, 2 is -1 times -18, which gives us +18. The solution in the document matches our answer, 18, so we are correct. We're doing great. Let's calculate one more cofactor from our example. For our third calculation, we'll find the cofactor of the element 9. The element 9 is in the first row, third column, so I is 1 and j is 3. Its position is 1, 3. Using the formula, a sub 1, 3 equals -1 to the 1 plus 3 power times m sub 1, 3. The exponent is 1 plus 3, which is 4. This is an even number. -1 to the power of 4 is +1, so the sign is positive. Next, we find the minor m sub 1, 3 by crossing out the first row and the third column. The resulting minor is the determinant of the 2 by 2 matrix with elements 2, 4, 8, and 7. The value of this minor is 2 times 7 minus 8 times 4. This is 14 minus 32, which equals -18. Now we combine the positive sign with the minor. The cofactor a sub 1, 3 is +1 times -18, which is -18. Looking at the solution in the document, they also arrived at -18, confirming our result. Excellent work. Let's quickly recap what we've learned today. We started by defining the cofactor as a signed minor. We then introduced the formal definition using a formula. This formula, A sub ij equals -1 to the power of I plus j times m sub ij is the key to all our calculations. We saw how the exponent I plus j gives us the correct sign, positive if it's even and negative if it's odd. And we practiced calculating cofactors for specific elements in a 3x3 matrix, breaking down each step to find the position, the sign, and the minor. You are now equipped to calculate cofactors. In our next tutorial, we will use this knowledge to tackle how to calculate the determinant of a 3x3 matrix. Thank you for watching this tutorial from Math Zone African Motives. To continue expanding your mathematical skills, be sure to subscribe to our channel for more videos. Subscribe for more tutorials from Math Zone African Motives.